back to stoichiometry. Let's do an actual stoichiometry problem, okay? So again, we're working with the combustion of methane. Let's say we have plenty of oxygen. So when we burn methane at our homes and our stoves, there's plenty of oxygen. The limiting factor is usually the methane. Let's say we have 12 grams of methane. And what we can do is figure out how much product we get. So let's say we want to figure out how many grams of water would be produced if we burn 12 grams of methane. So we want to start with what's given, 12 grams of methane. And we want to convert that to moles so we can use this mole ratio. Remember, this mole ratio is what's new. So we're going to use the molar mass of methane right here. That's going to be 12.01 plus 4.01. So that's 16.05 is equivalent to 1 mole of methane. The grams cancel out. All right. Now we can go from moles of methane to moles of water because we know it's a 1-to-2 ratio. Where we're going to put the 1, going to put it down here. 1 mole of methane is equivalent, chemically equivalent to 2 moles of H2O. So that cancels out. Now we could stop here and we'd have moles of water. This problem wants us to convert to grams. So then all we need to do is multiply by the molar mass of water. 1 mole of H2O. And then just get out your calculator and let's see. So we'll take 12 times 2 times 18.02 equals, then we'll divide it by 16.05. And that looks like, let me put my glasses on here. That looks like it's, well, we got 26.94579, but of course, we're starting with 2 sig figs, so we should use 2 sig figs, so 27 grams of H2O. All right, that's pretty typical stoichiometry problem. Let me give you a little flow chart you could use, might help you. Let's say this is moles of A, and now what we have is another heart. We have moles of B. So what we're doing right here is going from moles, in this case from moles of methane to moles of water. So to go from moles of something to moles of something else, what you want to do is use the coefficients. Use the coefficients. And that's what's new. So we're going to be given, I mean, we could give you number of molecules. If we gave you number of molecules, we'd use Avogadro's number then. We would divide by Avogadro's number. In this case, we started with the mass. Whoops. Mass, so we divide by the molar mass. Go through that first heart, use the coefficients. And in this case, we wanted to get to the mass of water, so we multiply by the molar mass. If we wanted to figure out the number of molecules of water, we would just simply multiply by Avogadro's number. So that's a nice little flow chart. Just remember, start with what's given, convert to moles, use the mole ratio, and then convert to what you're asked to convert to. So we'll do more of these problems. This is the second video on stoichiometry. Remember to review all 5 types of reactions, all 5: combustion, decomp, synthesis, single replacement, and double replacement. All right, thanks.